Welcome to tutorial on quantum chemistry part 2. For this part 2 we will be discussing Bohr equation. This is Bohr equation and Rydberg equation. Since energy and wavelength are mathematically related, the Rydberg equation can also be expressed in terms of energy. Look at this question. What is the wavelength of the photon that will cause an electron in the n quantum number equal to 4 energy level of a hydrogen atom to jump to n equal to 6? Written here is Bohr equation, and you can use either in positive form or negative form, depends on the transition of the electron. Now, since the question is asking the photon required to cause an electron to jump from 4 to 6 means that the energy is positive. And now let's replace the n, the orbital quantum number. Initial n is 4 and I, and f, final quantum number, is 6. So based on the calculation, the energy or photon required to make sure that the electron jump from n equal to 4 to n equal to 6 is 7.566 times 10 to the minus of 20 joule. So this energy of photon will be equivalent to the energy of electron. As you may already know about the Einstein relation with frequency, energy and frequency, and we can also rewrite the frequency in the form of speed of light over lambda, and we can rewrite the energy related to Planck constant times c over lambda. Since the question is asking the value of lambda of the photon, then you can use this relation to calculate the lambda.